Hello everyone. In the previous video I have given a problem which is like this, that is a 3-inch parabolic arch of span 40 meters and central rise of 6 meters, carry a point load of 100 kilonewton at a distance 12 meters from the right hinge. Okay, this is the previous problem where we find out the reactions, bending moment diagram, and also we find out normal thrust as well as radial shear. Okay, this is the previous problem, and if you have any doubt in this problem, just refer my second video so that it will be helpful for you. Okay, today we will see another one problem. It is similar to the previous one. Here they are given a 3-inch parabolic arch of 20 meter span and 4 meter central rise, carries a point load of 40 kilonewton at 4 meter horizontally from left support. We have to find out bending moments in the arches, and we have to plot the bending moment diagram. Here they are not asked you about normal thrust as well as radial shear, so there is no worries about normal thrust and radial shear. So based on the data I have drawn the figure which is like this. Okay, I considered a arch, 3-inch parabolic arch. I considered A, B and C are the hinges, and the span of this one is 20 meters, that what they are given, and the central rise is 4 meters, that what they are given, and they also given another one, point load of magnitude 40 kilonewton, which is acting exactly at a distance 4 meters from left support. Okay, that what they are given in the problem, so that what I written here. Okay, so here every hinge will have two reaction, one horizontal, another one is vertical. I considered horizontal as HA, vertical as VA. Similarly, I considered horizontal reaction here as HB and vertical reaction is VB. So our first step is to find out the reactions. So in order to find out the reactions, we are following the same procedure what we followed for the beams. Okay, so first I am considering first equilibrium condition, summation of f of x equal to 0, where I came to know HA and HB are same. I consider that one as H. Then I am considering next equilibrium condition, summation of f of y equal to 0. Then I came to know VA plus VB minus 40 will be equal to 0. Then VA plus VB will be equal to 40. I consider that one as equation 1. After finding, that is after applying two equilibrium condition, I am considering next equilibrium condition, that is moment at A equal to 0. Yeah, see here, moment at A equal to 0, we have two forces acting at point A, but there will be no perpendicular distance with respect to A. These two will become 0. 40, we have perpendicular distance of 4. It tends to rotate clockwise positive. HB, so line of action meets point A, so it will become 0. We have only VB. It tends to rotate anti-clockwise and its perpendicular distance is 20. Okay, that's what I have written here. From that equation, we came to know VB value is 8 kilonewton and VA value is 32 kilonewton. After finding that, next step is to find out the horizontal force, HA or HB, or we can say that one as commonly as H. Okay, that is horizontal thrust. Okay, so in order to find out that one, you can consider summation of moment at crown apex point or moment at C equal to 0, either for left hand side or for right hand side. I am considering here for right hand side because left hand side we have a point load. It is bit difficult. If you consider this one, it will be bit easier. That's the reason. So I considered two RHS. Okay, it is shown here. Moment at C equal to 0, right hand side. So right hand side we have only two loads, that is two forces, one is H, another one is VB. Okay, so H, it tends to rotate clockwise positive. For this it is the perpendicular distance is 4. For VB, perpendicular distance ear to ear, it is exactly half of the span, that is 10 meters. Okay, but it tends to rotate anti-clockwise, so it is negative. Okay, that what I have written here. And we came to know HA, HB, that is 20 kilonewton, that one in turns equal to H. Okay, then we can easily find out the resultant of the two components, that is one horizontal, another vertical component, H and VA. So we can find out the resultant RA by using this formula, and RA value came to know 37.735 kilonewton, and its direction, it is tan inverse of vertical by horizontal. Okay, if you consider that one, you came to know the direction with respect to point A. With respect to point B, so we have these forces. With respect to point B, we have these forces, and if you apply same formula here, you came to know what and all are the reaction with respect to B as well as the direction with respect to point B. After finding the reactions, next step is to find out the rise and slope equation. For that, we know it is a parabolic arch. They are given, we know that is for a parabolic arch, y equation will be 4hx divided by L square whole multiplied by L minus x, where L is a span, it is 20 kilonewton, and h is a rise, it is 4 meter. Substitute this one in the above formula, you will get this equation. That equation is called as a rise equation. If you differentiate this equation with respect to x, you will get another equation that is called as a slope equation. Okay, that what it is shown here. Okay, after finding rise and slope equation, next step is to find out the or to calculate the bending moment, and then we have to plot the bending moments in the arches, and we have to draw the bending moment diagram. Okay, so in order to find out the bending moment, or in order to calculate the bending moment, we should know that at the hinges always bending moment will be 0. Okay, we have 3 hinges at point A, B and C. So at these 3 points, bending moment we will consider directly equal to 0, and we have 2 different portions. As I told earlier itself, wherever load is acting, you have to consider that load as a first, and then you have to consider the another section whichever the load is not given. Okay, in this problem, load is acting at point D, that is at point D that I was shown in this figure, that is at point D we have a load of 40 kilonewton, so which is acting at point D, it is at the 4 meter distance. So I am considering only this portion now. That it looks like this. So we have a point load 40 kilonewton which is acting at D, and it is 4 meter from a left support, and we know horizontal force it is 20 kilonewton, and we know vertical force it is 32 kilonewton. Okay, and we know moments at the hinges are 0, and we have to find out bending moment with respect to point D. So for that, we 40 kilonewton is acting at point D, so it will become 0, and we have horizontal force. I told you earlier, horizontal force consider always negative. Vertical force moving upwards produces positive bending moment. Vertical force moving downwards produces negative bending moment. Okay, so here we have only one vertical force, it is moving upwards, so it will produce a positive bending moment, and we have horizontal force 20 kilonewton, it produces negative bending moment. For 20 kilonewton, perpendicular distance is YD. For 32 kilonewton, perpendicular distance is 4 meter. So YD we don't know. For that we know the rise equation that I will tell you while explaining the problem. Okay, you can see here bending moment at point 2, it is minus 20 into YD plus 32 into 4. Here YD is the unknown, but we know rise equation is this. If you substitute x value as 4 in the rise equation, you came to know the value of YD. Okay, that is 2.56 meter. So here to here vertical distance is 2.56 meter. If you substitute this one in the above equation, so you came to know what is the bending moment exactly acting at point D. Okay, that's what I given here clearly. So we came to know that bending moment at point D is 76.8 kilonewton meter. That is horizontal force 20 multiplied by YD, its value is 2.56, plus VA, its value is 32, multiplied by 4, you came to know the bending moment at point D. So there ends one portion, that is A to D. We have to calculate for another one portion, that is where the load is not acting in this problem. So that is portion B to C. There we have to consider an imaginary point which is at a distance X from the horizontal and its vertical distance is Y. Okay, likewise we have to imagine and we have to solve. That I will tell you now. Yeah, now I considered portion BC. That you can see from the previous problem. Just this is the problem what we are given. So I am considering only portion B to C. That what I have written here. Okay, B to C. And I am considering a imaginary point X. So it is at a distance of X with respect to right hand side, and vertical distance I am considering it as Y. Okay, then we have to find out bending moment with respect to this point. We have two forces, one is horizontal, another one is vertical VB. Okay, so bending moment with respect to this point minus, because horizontal, minus H multiplied by Y, and we know vertical VB multiplied by X. Okay, that's what I have written here. And here unknown is X as well as Y. So for that, what I am doing means I am substituting, we know Y rise equation. I am substituting the rise equation as it is in the above equation. Okay, then I am simplifying this equation. So you will get 8x minus 16x plus 0.8x square. Further simplification, you will get minus 8x plus 0.8x square. See, wherever you will get a maximum bending moment, at that point you know that partial differentiation of the maximum bending moment will be always equal to 0. So I am applying the same here. So if you partially differentiate this one, then that will be equal to 0 if you consider, then it will be minus 8 plus 1.6 x square, that will be equal to 0. From this equation I can easily find out the x value. Okay, then it will be minus 8 plus 1.6x equal to 0. So x value will be 8 by 1.6, that will be equal to 5 meters. Okay, substitute this 5 meters in this equation 2, then you came to know the maximum bending moment which is acting at a point X. So that X is exactly at a distance 5 meter from the right. That what we find out from this. Okay, and you substitute unknown value of X in the equation 2, you came to know what is the maximum bending moment you have. Okay, after finding bending moment, next step is to draw the bending moment diagram. So positive, if it is, you have to draw above the axis of arch, and if it is negative, you have to draw below the axis of arch. And you should remember that at the supports it will be, at the hinges it will be 0. So I am considering at A it is 0, at C it is 0, at B it is 0, and at point D we have a value, it is 78.6 positive, so above the arch. And at point X we have a value, it is minus 20, so it is below the arch. Okay, below the center line of the arch, that's what I considered. And it is a point load, so I drawn an inclined line here, and here there is no load, so inclined straight line I drawn. Okay, That's how you have to draw the bending moment diagram. There ends your problem. Okay, in this problem they are not asked you to find out normal thrust and radial shear. That's the reason we are not solved normal thrust and radial shear. We will see some more problems related to the arches in the upcoming videos. That is it consisting of UDL as well as combination of UDL and point load. Okay, that we will see in the next videos. Thank you.